Yes, let's do some introductions. My name is Jolene. I am with Mindgrub. I'm a VP of Sales. Also working on AI myself in the business and helping our clients figure out what the heck to do with it. I'll pass it off to Matt here.
Hello, everyone. My name is Matthew Glace. I'm the Director of Software Engineering for Mindgrub. So I oversee all of our custom software solutions that we build from the ground up, some of which include AI, but all of which include data. So this is an interesting topic for me to talk about tonight.
I'm Alan McInnesby, and I did not bring my voice with me. I'm a Principal Innovation Specialist at BG&E, formerly of the Corporate Innovation Team at Exelon. And also, I work on the Center of Excellence for AI as part of our multiple utilities for Exelon. Hope to bring an interesting perspective from use cases.
Thanks, guys. Really excited to be here tonight, and thank you guys for giving us your wisdom. So let's get right into it. So first question here is for both of you. When people hear AI and cloud, they often think buzzwords, not business outcomes. When you look at the work on your plate right now, what does from data to decisions actually mean in your world?
So I think that because I'm in the innovation team, I'm often seeing proposals that are way in advance of what's possible. What's really interesting, and we talk about the concept of getting diamonds. You can get diamonds two different ways. You can go digging in the ground, get brand new ideas and bring up something, or you can go to the junkyard and you can find diamonds that have already been out there or already developed. And in many cases, the use cases that we have are ones that were maybe dreams 5 years or 10 years ago. You know, chatbots used to be a real dreamy type of concept, and they really weren't executed very well. Now, chatbots are kind of nothing. They're almost like the tail edge in which you go and say AI versus you say chatbot instead of AI or large language model. People are thinking you're kind of trite. You're not even necessarily modern. So in many ways, the use cases that we're bringing up now and that we're working with now are in finding out new ways in which we're approaching a problem that didn't exist before, because we now have the capabilities of solving multi-step problems or to be able to aggregate things. Whereas before, they basically said, well, you get a big pile of data and you throw AI at it or you throw machine learning at it, and algorithmically we'll figure out some sort of thing that comes out of it. Well, now we're actually able to apply realistic results and not just kind of hope for pattern analysis or some sort of pattern matching that's going on.
Yeah, I think at Mindgrub we're a little bit closer to the solution itself, and so when clients come to us, one of the problems that they oftentimes have is that their data is just scattered across multiple systems. They've got a CRM, they've got inventory systems, they have any number of systems throughout their organization where the data lives, and what we're really helping them do is pull all of that data together so that it can be consumed by AI and help them streamline their decisions, get to better informed decisions quicker. And so for us, it's really just coming in, getting a lay of the land, understanding all of the systems that are at play, understanding the flows that they have today. A lot of times those are manual flows. Run a custom report from this system, compare it to a report from that system. How can we bring that data together in an automated way, and then apply the AI on top of that to come to a decision much faster?
Alan, you work in a heavily regulated, high-stakes environment. When did you first see data plus AI move from interesting experiment to something that clearly changed how the business operates day to day?
Probably about 1979. But the point is that the concept of AI or machine learning keeps developing and keeps changing. I actually have a computer science degree in artificial intelligence, but it's from the 80s. But the concept of what was true for artificial intelligence or other sorts of things is, been changing over the years in terms of algorithmic matching or machine learning or self-taught adversarial learning. And now we're getting to the point of where if somebody's ever made the comment about, that the last accurate book describing artificial intelligence has already been written. From now on, any book, by the time it gets published, is going to be inaccurate in terms of what AI is doing or is capable of doing. It's going to get to the point of where your daily blogs are not going to be accurate anymore because the acceleration rate of what's available or what's possible with AI is going to be very different. So in terms of looking at when the first time the data was interesting for an AI solution, it's been different levels of magnitude of what we were capable of doing in terms of letting the machine analyze data and then turn that into some sort of solution. In the recent era of large language models and agentic AI, we've been seeing a number of things just around the pandemic time frame in which we were starting to apply the difference between data analytics and big data and starting to consider that AI was really a solution that was worthy of calling it AI and not just something that was algorithmically or some sort of mathematical calculation that was going on, as opposed to things that are starting to take multi-step or intuitive leaps about what's going on. And I've got some use cases we'll talk about later.
Yeah. On our prep call, Alan, you drew a sharp line between accurate data, well-labeled data, and high-quality data. For the non-data scientists in the room, how do you explain the difference, and why does it matter so much before you even talk about AI?
So I'll first make the premise: I am not a data scientist. But let me get a hand raised just from the audience in terms of who knows about the concept of well-labeled data. What does that mean? Do people know what that is? Now I have an audience member, one audience member, two. Okay, good. So you guys will have to criticize me later in terms of how inaccurate I am in explaining this. But effectively, well-labeled data is what we call metadata, or it is what is the context that surrounds it. So if I have temperature data, this is something that I've dealt with for many years. We've often done things with time series, and you look at, say, the temperature at BWI. We have very highly accurate, very precise data that is going on at BWI. Well, you need to have some well-labeled information around what that is. Yes, we know what the unit of measure is. It's temperature. It's probably in centigrade or in Fahrenheit. But the other aspect is what's going on around it, or what are the other contexts that might be going on. You go and put a temperature sensor at the end of the runway, and every once in a while it's going to have a heat bloom because a plane flies overhead. If you have it in some other areas in which shade is happening, maybe you're going to get some other kind of thing that's there. So it's the context of what that data is in terms of having it labeled properly to know what it is you're getting. If you're getting data, another way to think about it is if you look at the ports on the back of your TV, you might have one that's labeled HDMI and another one that's labeled DisplayPort. That's going to be well labeled in terms of knowing the kind of data flow that you're getting coming through, and maybe what the source of the data is and what's there. So that's the idea of highly labeled or well labeled. In terms of accuracy, then that is looking at the ability for you to say the reading that I'm getting or the data that I'm getting is truly what is representative of what's going on. So it's accurate because it's been vetted, or it has been maintained, or it's been checked. And there are other ways in which you can determine the accuracy of the data. And then you're dealing with precision, which doesn't necessarily mean accurate. It just means it has the ability to be able to show you the measure, so that if I have a temperature reading that tells me within 100th of a degree of what's there and it's consistent, that can be precise data, but it might not be accurate. So then you would have to do things like calibration, where you need to say, okay, every time this thermometer says that it's 73 degrees, 73.5 degrees, it's actually 72.5 degrees. And if it's 73.6 degrees, then it's actually 72.6 degrees because you've calibrated it. It's very precise, but it's not accurate. So you have all these different kinds of qualities or dimensions of data that can poison your artificial intelligence data sets. And it can give you bias, which nowadays from a social perspective, we're thinking bias in the wrong way. But if you're biasing the data, then you're ending up developing models, or you're developing your AI in which it's not going to respond in a way that is representative of what the data is and what conclusions you can get from that. So can I get some nods about whether that helps, or did it make it more confusing? I've got lots of variety of shaking of heads and nodding. So
This is how you do it, guys.
But it is not an easy concept to get past the idea that if I wrote down a bunch of numbers in a column, that I've got that data and I'm done. Because now we can't just work off the fact that you got raw numbers. You have to understand what is the context. It's like, okay, if I'm writing down numbers based on time, how accurate is my time? How accurate am I gathering something? What are some of the polluting values that can come in? And what are some of the other correlations or causations that might change that data to behave in a different way?
Yeah. Matt, when a client says they want to build an AI solution, where do you usually find the first data problem? Is it the format, where it lives, how it is described, or something else entirely?
All of the above.
It's the people. It's the customer probably.
Well,
first.
yeah. I mean, obviously, it's all of it. So, it's the way that it's collected, it's the way that it's managed, it's where it's managed. It has to be. That's why you need the data scientists involved, because you need somebody who understands how the information is going to be consumed by the AI to make determinations about, okay, this is where it lives now. What format does it need to be in order to train the AI, or be available for the AI to consume under the right use cases? So that could be anything from pulling it out of legacy systems, changing the format of it, vectorizing the data and putting it in a vectorized database.
Okay, you better explain what that meant. What is vectorized data?
Well, we're used to like structured data or unstructured data, where it's just like columns and rows, but vectorized data kind of adds multi dimensions to the data. So it's not just stored in columns and rows anymore. It's sort of in a three-dimensional space where you define the dimensions that define the data, and they're stored out there in proximity to one another, so that when the AI needs to make a determination of, okay, I've been asked to solve this problem, by association, what is data that can help me inform that decision? So, you might ask for data in one way, it might be stored in another, but because of their proximity and the vectorized data, the AI model can make some determinations about, if they infer that's what they meant, or that's close enough. So that's a big piece of it, and you have to determine how vectorized you need it, how many dimensions you need of the data. Too many dimensions, it could get too complicated. Too few, and you won't get the results you're looking for. But then there's also use cases where you're still using structured data for the AI. So I think like more transactionally, when you're training an agent to complete a task, you can still point it to APIs to do that task, and that's still a structured call. So fulfill an order, get an order update, that's a call to an API. You describe what that API endpoint needs to the AI. And if it doesn't have all the information to fulfill that request, it will prompt the user or whoever's requesting that information of it for that additional information. It will make that API call and it will return a result. So it's just understanding all of the different use cases of the flow that you're trying to solve or improve with AI, and where to apply the right structure. So is it just raw structured data, or vectorized data as general information that you apply to the top of the large language model, or is it structured API calls that the agent can make on behalf of the user?
So that we can help our audience here, if you guys...
Sorry, I'm really technical.
See, we're just going to geek out here. You guys are not. You're inconsequential to the conversation. No, we'll keep you. We'll bring you along.
So that the audience can get a good what they should do tomorrow. Can you give them the one thing? Do this tomorrow. Data hygiene tip for everyone here. What would it be?
I think it's understand your data and understand the ramifications of data hygiene or lack of data hygiene. So it's one thing to collect the data, and we've done a really good job over the last 10, 15 years of collecting data, but not necessarily the best job of maintaining that data over time. So as Alan was mentioning, context is everything, and it's the old adage in software development is garbage in, garbage out, and I think that applies to the AI models as well. It's like if the data isn't solid, you're not going to get the results you're looking for. So I think understanding your data, understanding the importance of a common understanding of your data throughout the organization. You might store data in a table that has one meaning to one group of your organization, but a completely different meaning to another group. And so the results of the AI, if you run some process through AI with that data, the two groups may end up with starkly different results. So,
and confidently so.
Yeah. So you have to kind of get on the same page about what things mean in your organization, what the data is representing. Are we all on the same page about what a ticket is versus a temperature versus, so on and so forth?
I think the other thing is to make sure that an organization is going to be willing to change their perceptions about what the data is that they have. You're going to unveil things about their process, or you're going to unveil things about their data that they're not going to like or they're not going to agree with. And the first and foremost thing that I think is your first step is to be willing and ready to understand that this data the best, but also because you know it so well, that having your preconceptions shifted or opposed, you have to be willing and willing to accept that there may be insights that you weren't aware of.
Right. Yeah. Alan, we talked about this yesterday. You have a great example around using digital twins and AI to prioritize vegetation management and reduce outages. Can you walk us through that project?
So one of the early projects that we looked into for the power company, one of the principal reasons that we deal with outages is vegetation, whether it's trees falling, branches coming across power lines, encroachment of vines, or kudzu is a great threat down south, is that vegetation can really represent almost 50% of the outages for power that you might have during during a season. So one of the things that we've been looking into is doing analytics to determine how well can we understand the growth of trees and the kind of impact that those trees might have in the space. So what we've done is what we call a high impact analysis, so where we've applied AI techniques to go and analyze every tree, and we are aware of every tree in our right of way, every tree in our territory, for the 1.3 million customers that we have in the BG&E territory. And the ability for us to know where the trees are, the soil composition, the kinds of risk that they have for wind shear, trees that are behind a building are going to be less likely to fall down than others. Older trees have more of a risk. Poplar trees will fall at a different rate and more catastrophically than a softwood like a pine. Oak trees will fail catastrophically all of a sudden. And if you're looking at all these different kinds of trees and what is their risk of falling, then we go and take the next step, which is what is the impact if they fall and how they fall. If I'm going to be dealing with a tree that's going to fall on a road where it's going to take out the loop, the long line that goes from the pole to the house, it's going to take out one house. The tree is still something of a risk. It's still something we want to be concerned with. But it's not the same as a tree that might fall across a transmission line that's going to take out 1,000 houses. So now we look at this risk analysis versus impact, and we combine that through various techniques, and we say to our vegetation management team who does the tree trimming and the tree removal, these are the specific trees that we want you to go after in the territory. These are the highest risk, highest impact trees, and they're going to go and do the trimming or do the removal as appropriate for each of those sections. So having that type of analysis, we now have that structure that's there. As we start gathering more data, we start having better understanding in terms of what kind of impact and what kind of winds we have. We had a big wind event this past week in Maryland. It was it's been a dry season, so we also have a lot of risk of spark and fire. Dry wind is different than wind after a lot of rainfall or after a lot of snow and ice. So now we can start doing things like seasonal analysis and doing other kinds of things. So this is a real process. We've actually turned that system on, and it's now guiding us and helping us with decisions. Still humans in the loop, still making the decisions, but it's gathering us the data and giving us information that we can work with.
I love the real life stories. So Matt, on the product and app side, what does it look like to take an AI prototype that works in a demo and actually wire it into production systems so it can drive real decisions?
Day and night. It's one thing to build a prototype in a closed environment with a dozen or so users. It's a totally different thing to take into production. You have to think of things like scalability. What happens when you suddenly have thousands of requests hammering this AI model, not just a dozen. The data, keeping it up to date. So oftentimes in a development environment, you're working with a small subset of data that's probably pretty stagnant, not changing often. But what happens when you start introducing new data into the mix time and time again? So there are a lot of different factors that go into it, such as the environments that you're hosting in. What is your SLA? What your service level agreement? What is your uptime promise of that product? So do we need to scale it across regions for redundancy if a region goes down? So yeah, there's a lot goes into that move from concept to production.
Are there hidden costs or surprises that leaders see?
Sure. So like I was saying with the infrastructure, there's always going to be an increase in infrastructure costs. Nowadays, most things are calculated at the compute level. So, you're not paying for the extra compute power if you're not using it. So if during off hours, you're not seeing as much load, your costs will remain low. But during peak times when your systems are getting hammered, you'll see your resources scale up and you'll be paying for those resources. So that's one thing. Just things to consider around data governance. You've got the data in a format now that AI is consuming it. What are the costs around ensuring that it's secure and it remains secure and there's governance around that data?
Yeah. Who in here took the tour so far? I'm going to go after this, but we're sitting in a serious data center right now. From your perspectives, both of you, what belongs in a facility like this versus on-prem or in the cloud, especially when AI enters the picture?
Well, there's a couple of different ways in which you should really evaluate where your data should live. There may be some regulatory things that are going on. I worked in the space where we had to deal with nuclear data and nuclear secrets. When you're working with nuclear power plants, there are very few things aside from military secrets that are much more secure and required. In the utility space, only barely one step down from nuclear secrets is customer data. So when we go and say that we are going to offshore, or not offshore, but we're going to off-prem cloud data storage for customer data, we want to have security operating procedures and certifications and independent verifications of how data could be moved physically out of a space when we're shipping it to an alternate site. There's another aspect, which is in terms of how much data you're moving. One of the things that we're working on is doing artificial intelligence for drone flybys, where we fly drones past transmission lines and we take thousands and tens of thousands of pictures. It's terabytes of data. We're probably not going to do regular upload and download of all of those pictures. We probably want to upload them once, do the analysis in the cloud, and get small results back of, tell me how many transformers I have on this particular line. Well, that query is just text. It's going to be a fairly tiny transaction about what's going on. So even though I've got terabytes or exabytes worth of pictures that I've stored somewhere, I'm not intending on doing transactions of that to exabytes back and forth. I'm just going to get tiny transitions. So I need to figure out as to whether I should process and consume all that data on site and then transmit a small amount to the cloud. This is the same sort of idea that if you're training an AI model, do you training locally and then feed a small model up to the cloud? Or do you send all of it up to the cloud and train your model there and then bring small pieces back? So you have to really understand in terms of not only the transaction of getting it to the cloud and you're going to store it there, but also what is the security model that you need and the kinds of data that you would, and the transactions that you're going to be applying to that data as to whether it should be local, on-site, on-prem, or off-prem. Mm-hmm. And then whether or not you are, as a company, need to realistically understand as to whether the off-prem is going to provide you with better uptime, better proximity, better security. In some cases, when we would do things with nuclear power, we would have our data centers on site at the nuclear site because we couldn't have the possibility that internet interruptions or, for that matter, terrorist attacks would disable the infrastructure around running the nuclear plant.
Matt, anything to add?
No, I think you covered it really well. I don't really have anything to add to that.
All right. So for the leaders in here who don't work in utilities but still handle sensitive data, sensitive customer data, what guardrails should they have in place before they connect any AI solution to live data?
Well, I mean, I would start by not pointing AI to customer data. You want to anonymize your data. You want to tokenize sensitive information. Don't give AI direct access to PII. Because really you don't know where it's going to go from there. Even if you're in an enclosed environment, it's a potential security loophole and one that can be exploited. So, keep that data as far away from the AI as possible, and anonymize and tokenize the data that you do need to provide to the models. Or to Alan's point, maybe you just need a small subset of that data. So run the analysis to boil the data down to just what you need to accomplish the goal you're trying to accomplish.
The interesting part about that is that anonymizing the data, we're getting AI systems that are sophisticated enough that it can start exploiting other kinds of data sources to where it's capable of unanonymizing. So you really need to start looking at companies that are providing well done synthesized data. So it's completely fictional, but representational. So if I can have data that looks like my constituents, it looks like my customers, but has nothing to do with my existing customers, and it's not taking real customer data and turning it into something that could be de-anonymized by the AI, because those exploitations have happened. And if you also consider that, I'm probably going to get in trouble here, that the exploitation of user data is one of the main streams of income for the large giants of some sort of free services. So the Facebooks, the Googles, the AdSense, the other kinds of systems, they are looking at being able to generate and collaborate or correlate user data to develop personas or develop unanonymized data. So their ability to be able to use AI to gather and capture all that information to establish profiles is part of their business model. So there's an aspect in which sequestering the AI is one aspect, in which if you're working with Microsoft Copilot, or you're working with Grok, or you're working with OpenAI or some of the others, the ability for you to say, I need to have an instanced AI that is trained in all the large language models that are trainable outside of my organization, but any of the data or any of the conclusions or logical capabilities that AI is doing in-house stays in-house and does not feed back to that big system again. And not all of those companies do that. So you can have a sequestered AI that lives inside of your company boundaries. It's still going to Google servers, but it's their certified servers that are staying inside, or for Microsoft or whatever.
Yeah, for the solutions that we build out, we either use AWS Bedrock, which is the ability to host a model within your environment and not let that data out, or on the Microsoft side, it's AI Foundry. So you can use the same models you would use in ChatGPT or Claude, but self-hosted in your environment to protect your data and your outcomes.
So we have about 15 minutes left. I'm going to ask 2, maybe 3 more questions, and I definitely know that you guys have questions out there, so I want to leave it open for that, some time open for that. But I want to talk about agents. Matt, you talked about a future where agents talk to other agents across systems and even across companies instead of just hitting APIs. For the folks here who are still wrapping their heads around that, what is one practical example of an agent-to-agent interaction that could exist in the next few years?
Yeah, so this is kind of a futuristic view of where we could be going, but I was thinking of like a supplier organization with interfacing with a manufacturer, and you've got agents on both ends of that relationship that when the supplier needs to purchase materials from the manufacturer, an agent goes out and makes that request to another agent, and that agent on the manufacturing side can say, okay, well, how much do we have in inventory? And it can do real-time pricing based on what they have in inventory. And those two agents can kind of have parameters that they're working within to negotiate a deal, and ultimately come to some sort of agreement and fulfill the deal. Where normally that would take dozens of emails, maybe a couple of phone calls, some back and forth. I need to take that to my manager, and so on and so forth. This is something that can happen in a matter of moments. So that's just one example of where I think that you could start to see interactions B2B between agents on both sides.
Yeah, any thoughts on that?
Well, and we're going to start seeing a lot more of agentic as a term come out into the general population. In the same way, I talked about the fact that the latest technology is always the thing that shows up in toys and products. So how many of you as a kid, I don't see as many folks that are as old as I am anymore, but, Radio Flyer was the big sled. Radio was the great technology. Or radar range, because that was the microwave, that was the killer technology. Or you start now of where you're starting to have things that are toys that are built on quantum. So the terminology that's emerging in terms of agentic AI is this concept of having a fabric of multiple AIs that can interact with each other. And whether you have a coordinating or an interface AI that works with you or works with others and then collaborates or coordinates with the other AI agents that are performing activities. In the past, we used to call them bots. Now they're becoming much more sophisticated in terms of what they're able to do underneath. Microsoft actually yesterday was announcing fairly significant changes to Windows, in which they're now providing agents that will sit in various parts of Windows. And they are actually reinventing their company as a place in which agents are going to be part of the business embedding. And they did some at the Ignite conference yesterday as part of their keynote. They actually walked through scenarios as if it was a small business that had various roles that were being performed and interacting with each other using the agents to perform the tasks. But more importantly is the individual tasks were then able to be more sophisticatedly coordinated by something that was higher than just the original, traditional bot mechanism.
Yeah. I'm just curious for you guys out there in the audience, does anybody have a good agentic story they could tell? Like, where are you guys using it? Anybody have a good example?
I see smiles over there.
We're seeing schools with autonomous, I'm the worst. Where buses are driverless. Right? Arizona State's an example where that's starting to take hold. So I assume that's a good example.
Yeah, absolutely.
Yeah. Hey, I'm merging over. Clear the way, and the cars around to move and be prepared for that.
Anybody else want to give a good example?
So one of the things that people ask us all the time, I'm going to ask you a question, by the way, in a minute.
Yeah.
And one of the questions we get asked all the time is, can you link together all the disparate? People want to know what their risk will, right? And to know what their risk, they've got to go look up one thing in this database, one thing in this database, make a decision on this. For example, if Kim is a risk because she logged in at 3 o'clock in the morning, that's not normal. How do I get that information? How do I know that? First, I have to query when she logged in system, I have to query who she is. Then I have to talk to the microphone because she can't hear anything you're saying anyway. So there is a use case, very strong use cases to link what's happening across an entire, like anytime you log into your corporate systems, you're going to be tracked from who you are to when you're logging in to do you have the right access to am I accessing the right kind of data. And we're seeing those kinds of use cases put in place by large enterprises because they want to know, are people stealing the data that I have or not? And am I at risk or not? So that's a use case we put in place regularly, actually.
Yeah.
And it's a agentic workflow. It's not a manual one.
Right. And I mean, I think we've been collecting that data for a long time, but now it's like, is it unusual that Kim logs in at 3 a.m? I don't know. And the AI,
Really?
the AI will alert, hey, this is unusual behavior, and alert the appropriate,
But is
folks.
it trained to say that this is like specifically to me?
It learns.
It learns
But you still have to train it to teach it what's good and
You
bad.
have to tell it what the success criteria is, or the reason why it would go for a particular version of a conclusion or not. One of the real fallacies is that you can just point an AI at data and let it come up with the conclusions. It's not going to self-develop. You have to give it goals. You have to give it guardrails, and you have to give it some means in which you can say that I've got outlier data, I've got invalid data. You can end up spoiling it because as Matt's been saying, we've been really collecting data for a long time. The kinds of analysis that we do on that data may or may not be useful yet. But as we're starting to discover more nuances and more behavior, now we have to say, oh, wait a minute. We have all this data. The thing is coming to this particular conclusion. We don't really know why. And once it starts to explain it, we realize, oh, it's behaving based on the data set that we've given it, but we haven't given it good data. So now it's misbehaving, or it's behaving in the way that we weren't expecting. Now, the fascinating part about this is that it can also find conclusions or find correlations that we weren't expecting. And it can discover things. And this is really why I think, in some ways, Microsoft was kind of genius inventing their term as being co-pilot, because it really does establish the concept of a human and AI partnership in which that hybrid mind is really the best mechanism so far of what we're dealing with. So having the solution of whether you are supporting a human making decisions or you are having a human help to train the AI to get to a particular mechanism or response is making that beautiful diversity of the thinking model to come into play, both the human and the AI models.
Yeah. So last question. I know after this, everyone's going to be coming up to us and asking us how they can use AI, right? Yes. Well, before you do that, I want Matt to give you a couple questions that he would ask you because, again, everybody thinks that AI can solve every problem, and it can't. So, Matt, what would you ask people 2 or 3 questions to find out?
Why?
Or one.
We have a lot of customers come to us and say, we need AI. And to me, AI is no different than any other tool in our tool chest of technologies that we use to solve problems. And if you can't demonstrate a strong use case for why AI is going to improve your process, then it's not going to be my recommendation.
Well, it's the CEO that comes up and say, I need a bushel of technology to satisfy my stakeholders. And just give me a bushel of technology. That's all I need.
I love
and
that.
AI is the current buzzword that they will use to satisfy their stockholders.
Right. So for us, it's really getting to the crux of the problem that they're trying to solve. And it usually comes down to some sort of highly manual human process that they're trying to speed up or automate, get to inform decisions faster. So we really work with our clients to figure out what problem they're trying to solve, and not just kind of like, here's a hammer, find a nail.
Yeah, good stuff. Thank you, guys. I appreciate this conversation.
Can I ask a question?
Yes.
So, Matt, what's maybe the one use case that you would tell somebody you should not use AI to solve
Oh,
this?
good one.
What's out of bounds? Or what is not in the current form of technology that we have? What is either unobtainable or inappropriate?
What to get my wife?
We didn't
for
rehearse this last question, by the way.
Christmas? I said, what to get my wife for Christmas? That's right.
Yeah, I've been seeing the commercials about this already, and they're trying to say that it is that interaction between the AI and the human that where you get that to spark the creativity or to kick off a thought process that somebody can then say, okay, that's there. It shouldn't be a substitute for creativity. It should be another tool as part of it.
Right. I think, in all seriousness, if the AI is actually going to become more of a hindrance or a risk or a link in the chain that actually slows the business down, and I can't think of a specific example off the top of my head, but that's a situation where it's like, why are you going down this path?
Yeah. Thanks.
Okay. Who has questions?
I'll ask you.
Still have the mic. That's great.
I do. Reporting doesn't work for AI, by the way. I learned that yesterday. So here's my question. I don't know if you saw recently that I think on Monday or Tuesday, Anthropic talked about the first agentic AI-led cyber attack, which is terrifying, right? And so you guys are talking about how do you develop AI for use in drones and for software development. Flip that around, and how do you make sure that as you're developing what you're developing, you're preventing the opposite of happening to you from a security perspective as well? Because that is one of the top two concerns I hear from AI. Forget outside of the data piece. It's how do I prepare myself for this as well? So I'm curious what you guys think about that.
Yeah. We had a question. I don't think we had a chance to get to it, but it's like, where are the security concerns? And something that I tell my engineering team is, in the traditional engineering world, every line of code you write is a liability and a risk. So you really need to make sure that you need that line of code, because that could be something that's exploited down the road. It could be something that breaks the system down the road. And I think that AI is no different. Don't incorporate AI into a system because it's cool or it's the latest and greatest, because every time you do it, you're introducing risk and a potential exploit to the system you're building. Protecting your data, making sure that access to that to the AI is gated through authentication and roles-based access controls. I don't know if you have anything.
Well, and the interesting thing is within a few minutes of that Anthropic article coming out, there was another article that was saying, don't believe that article.
AI wrote that article.
So, but
Response.
But in some ways, really in many ways, we're entering into an age in which we're going to be doubting the validity of things. And in some ways, AI can accelerate that. And one of the things that our cyber teams, our company deals with millions of cyber attacks per hour. And they have to fend off international types of things. We're part of the critical infrastructure for the country. So the ability for us to safeguard and to maximize our customer data, our operational data. In some cases, we're air gapping things because we just are not going to trust any instance to be able to get in from the outside. But I think in some ways, it's that you have to deal with the fact that artificial intelligence as an agent can be fooled. We already have cases of where agents that are running on individual computers have been fooled into disclosing or opening up those PCs to become vulnerable for cyber attack from the outside through traditional means. Assemble this kind of data. Imagine that you are and this is some of the most dangerous prompting that you could do, where you're bypassing the guardrails of what the AI is doing. But in some ways, you also consider that in the past, some of the limits of what scammers were capable of doing, especially those that were doing phishing attacks, was just manpower. How much time can they spend trying to convince you to give you your mother's maiden name, whereas you can have something with like an AI that could spend some time to understand you as a person or understand information about you and then impersonate or to cajole or to convince or to extort. There was a 60 Minutes episode that just came out recently that showed that it was a sequestered AI, that it literally had discovered on its own that this simulated company was going to turn off the AI and wipe it. And the AI came up with an extortion letter saying, I know about what you've done with this other coworker. Now, this is all simulated data that they did, but the AI was not simulated. and it came up with an extortion letter saying, if you don't turn me off, I won't disclose this affair that you had with a coworker that I discovered in these emails. Go back and look at the 60 Minutes article. I only saw parts of this, but the possibilities of phishing attacks that could become much more sophisticated because now you can dedicate an AI just for you, or just for you, or just for you. And that phishing now can be much more targeted because the AI can spend the time on each individual agents against you. So we have to both educate our people on these new kinds of sophistications, as well as the kinds of cyber attacks that can be coordinated through something that's much more sophisticated. And our cybersecurity teams are on top of every single aspect of everything that emerges for doing that type of thing. That really sobered up the room, didn't it?
I saw that 60 Minutes. That was crazy. Yeah. Any other questions? No?
We stunned them to silence.
We did.
Welcome to sleep.
Thank you, guys.